Okay, so now we want to move on to part B of the one-link planar robot. And we see there that in part A we found equations to find x and y in terms of L and theta. Part B gives us values for L is 5 centimeters exactly, meaning we should use infinite number of significant figures theoretically. We'll usually round to about 3 for engineering purposes. It wants to determine the values of x and y for the following values of theta. So it has a list of values there. And so I've rewritten this onto our engineering sheet real quickly. You can see we've got there, remember this is what we're talking about, we've got it, L starts from the origin is our vector, angle theta with the x-axis, and then we remember our two equations that x corresponds, since this point out here is xy, that it ends up at, the x corresponds with L times the cosine of theta, because it's the hypotenuse times cosine, we'll get this side. Y is L times the sine of theta, because y is L times, y is the opposite multiplied by the, if we multiply sine by the hypotenuse, we would get sine. Or, I said that out of order, but L times sine would get us the opposite side. So those are our values there, and then they've given us a list of values. Notice they're here, they're in radians. 0, pi over 6, 3 pi, they're radians, which is good. And so a couple different ways to go about this. For the most part, if you look at these are very common terms you would see on a unit circle. So one good idea is if we go at it from the idea of having a unit circle. I printed this one out online. You can find lots of these. You should definitely have one that you're comfortable using that has all the different things. When we look at the unit circle, we've got this one has both angle degrees and radian degrees, and then it gives us what. Remember, x again corresponding with the cosine and y corresponding with the sine for the different ones of these. And generally they will have things marked at 30, 45, and 60 degree angles and the corresponding angles in the different quadrants. So we would want to work with that. So the first one, we're asked, I'm going to go ahead and slide this up so we can maybe see parts of both of these. We're asked to find for 0 radians. And so 0 radians is really easy when we think about our circle. 0 is straight across. So we know that in that case it's all in the x directions, nothing's in the y direction. So we could use our equations, or if we just think a minute, we know, okay, if I have a 5 centimeter length that's all in this way, then all 5 centimeters are in the x, and none of it is in the y. And I've included units up there so I don't have to rewrite units every time for that one. Okay, so with 0, very easy. The next one is pi over 6. So pi over 6 corresponds to an angle of 30 degrees. The cosine is square root of 3 over 2. So if I want to get x, that's going to be 5 times, again, cosine is square root of 3 over 2. So it's going to be square root of 3 over 2. Which is just 5 square roots of 3 over 2. And for math class, that may be a good answer. They like to get exact numbers and that sort of thing. But generally in engineering, we like, if I tell you something's 5 times the square root of 3 over 2 centimeters that way, you don't have a good idea of what that means. So what we want to do is convert that to a decimal so we have a better idea of what that is. So let me grab my calculator here quickly. We're going to do 5 times the square root of 3, close parentheses, divide that by 2, make sure we've got things in the right place. 5 square root of 3 over 2, looks like it's the right stuff. So in engineering, we would call this 4.33. I'll just round it to 3 sig figs. That seems close enough for our case right now. So it's 4.33 centimeters in the x direction. And in the y direction, it's 5 times the sine, which is a half. So 5 halves is perfectly good. Again, in engineering, we'd probably want to change it to a decimal. And so it's 2.5. It's actually 2.5 exactly, but just so that it has the same number of sig figs as the other, I'm going to put it there. And I should underline that these are answers that I needed. And that'll help me because I'm going to use these again for another part, if you haven't looked ahead. 3 pi over 4, so 3 pi over 4, we come back to our unit circle. It's over here 135 degrees. What we notice about that, of course, is that we're in the second quadrant, so x is, we should get a negative number, y we should get a positive number. And so if we look, 5 times, and it's negative square root of 2 over 2 for the cosine, which again, for math class, it's fine to just write it as that. But if you're doing engineering, you probably want to make that a decimal. So 5 times second square root of 2 divided by 2. I forgot to insert my negative. So I'll go back and grab that. And so I get that it's negative 3.535. So I'll go ahead and round that up. So that's negative 3.54. So my x part is negative 3.54. My y part is going to be numerically similar, but y is in the positive direction. It's square root of 2 over 2. Or, again, for an exact answer, that's an exact answer. In engineering, we'll approximate that, and I can punch it in the calculator again, just without the negative sign. And it better come out the same. Yes, 3.54 is the answer there. The other thing I may want to consider on these is if I don't have a unit circle available, and I can't, or my unit circle for some reason doesn't have these points labeled, I can do the function in my calculator. What I would need to make sure that I'm doing at that point is make sure that I'm in radians. Notice here, mine is telling me that I'm in degrees, so if I try to put it in, I would get a wrong number. I could type it in as the degree number. I could say I want to know what 5 times the cosine of 135 degrees is, and it gets me the right value for x, the negative 3.53. But again, if I don't have it on the sheet, I probably don't have the immediate conversion there. So the better thing to do there is to go to mode. I'm going to switch it over into radians. And again, this is just how I have a TI-86. You may have a different way to get to yours. Now notice it's in radians. And so I would want to do 5 times the cosine of 3 pi divided by 2. And I just hit multiply instead of divide, so that's going to give me an error, or give me a wrong answer, not necessarily an error. Corrected that, so cosine of 3 pi divided by 2, that was the next question. Sorry, we wanted to do 3 pi divided by 4. And again, we get the negative 3.53. So a few different ways to go about getting it. All of them got us to the same answer. That's usually a good sign, and always a good thing to check your answers, even if you're pretty sure of them, if you've got the time. Okay, so that's 3 pi over 4. The next one is 3 pi over 2, and let's see if I can kind of shift. Which side is which? Maybe not. We'll cut this down a little bit. So 3 pi over 2 is our next value, and we want to get x, which is, so that one, it's all straight down in the y direction. So that's another one that's easy. I don't need to necessarily put in the formula because I know that there's nothing in the x direction, and in the y direction, it's negative 5. It's all that way. All right. So I kind of skipped past the third quadrant. We had one in the first quadrant, one in the second quadrant, one here on this axis. And then we'll have the last one, 5 pi over 3, is here in the fourth quadrant. So fourth quadrant, we expect positive x's, negative y's. We get 5 times the cosine. Remember, we want cosine of theta. Cosine is a half. So we get 5 halves, or 2.50 for that one. And for this y value, which is the sine, we have that it's negative square root of 3 over 2. Again, we expect it to be negative because y is going down here. So again, exact answer would just be to write it like that, but we generally want an approximation, so I'll go back. I'm still in radians, but that doesn't matter for this part because I'm just going to multiply it times the square root of 3 divided by 2, which is 4.33. And I lost my sign because I did not put negative square root of 3 over 2. Of course, if I just think about that, I don't have to necessarily punch that in my calculator again. I just have to remember to write that negative sign in there, or it's going to be wrong. And not just partially wrong, all wrong. So that's something to keep in mind. All right, so that's part B.